morning, we are going to take a look here at our section 6 notes, graphing linear inequalities in two variables. So we're going to work on this a little bit today, and then we're going to finish on Monday. So the first thing we're going to do is to remember that we've looked at graphing regular linear equations. So now we're going to look at a linear inequality. So we're going to have two variables, x and y, just like we had with our linear equations, only this time we're going to have an inequality symbol instead of an equals. So some examples here of some linear inequalities, they might look like this. So we might have y is greater than 3x plus 7. Or you might have an equation that is 3x minus 4y is less than or equal to 12. Or some other examples that you might have, might see, would be x is less than -1, or y is greater than or equal to 4. So those are just some examples of linear inequalities. The solution of a linear inequality is an ordered pair. So it's an ordered pair that makes the inequality true. So we want there to be a true statement when we substitute that inequality into the linear, when we substitute that ordered pair into the linear inequality. So our first example here, if we take a look at it, we have 3x minus y is less than 2. We want to go ahead and substitute that ordered pair in, that point, -2, 2, and see if is it a solution to that inequality. So if we substitute in -2 for x and 2 for y, is that a true statement? So I have -6 minus 2 is less than 2. So that is true. So -2, 2 is a solution to the inequality. So I want you to go ahead and pause the video right now and try to do part B on your own and see if the ordered pair 1, 3 is a solution to that inequality. Okay, let's go ahead and check this out. If I put in 1 for x and 3 for y, I get there 4 minus 3, or 1 is greater than or equal to 5. That is false. Okay. So 1, 3, that ordered pair, is not a solution to that inequality. Okay, so that is not a solution. So that's how you tell whether or not an ordered pair is a solution to an inequality. You substitute it in, just like we did with regular equations, and see whether we get a true statement or a false statement. And that determines whether we have a solution or not. Okay, so that's the first thing we're going to look at, is determining whether an ordered pair is a solution. The other thing we're going to look at is what the graph of an inequality is going to look like. So the graph of an inequality in two variables shows all the solutions of the inequality on the coordinate plane. The boundary line divides the coordinate plane into two half planes. So you can see here this boundary line, in this case, is a dotted line. That's the boundary line, and then this half plane right here that's shaded, all of the ordered pairs in that part of the coordinate plane are solutions. Everything on the other side are not solutions. So we're going to go ahead here and graph a couple of equations here. Just some basic things to remind ourselves as we get started. When we graph the boundary line for the inequality, we want to use a dotted line if we have a less than or greater than symbol, and we use a solid line if we have less than or equal to or greater than or equal to. So that denotes whether points on the line are part of the solution or not. So if points on the line are not a solution, we want to use a dotted line. If they are part of the solution, we would use a solid line. We're going to pick then a test point that's not on the boundary line to determine whether or not it's a solution, and then we will shade that half plane or part where those points are solutions to the inequality. So we're going to start off with some basic equations here like a vertical or horizontal line. So in this case, you want to think about y is greater than or equal to -3. So you want to think about the equation y equals -3. That's a horizontal line. So just a reminder of that from when we were graphing lines. So a horizontal line through y equals -3. Now our inequality symbol is a greater than symbol, greater than or equal to, excuse me. And because we have the equal to part, we know that our line is going to be a solid line. So we're going to draw a solid line here through y equals -3. So that we should be familiar with. Now our inequality says y is greater than or equal to -3. So all the points above that y equals -3 are solutions to the equation. So we're going to shade that part of the line to show that everything above the line here are solutions. We can pick a test point. The easiest test point to pick is 0, 0. So if I put in 0, 0, and I get 0 is greater than or equal to -3, which I know is true. So 0, 0 here is above the line, and that matches with what I was just thinking there, that everything above the line there is are going to be solutions to that inequality. All right, we'll move on here to part B here of example 2, and we will graph this line right here. So it's in standard form. If you think about the equation with the equal sign right there, x plus y is equal to 2. You want to think about that related equation, and that's in standard form, so I'm going to use my x and y intercepts. If I put 0 in for x, my y value would be 2. And if I put 0 in for y, my x value would be 2. So if I plot those points, 0, 2, and 2, 0, that gives me the two ordered pairs that I need to graph this. This is a less than symbol, so I know I'm going to have a dotted boundary line, dashed line, however you want to say that there. So there's my boundary line. Now I need to pick my test point. My test point is any point that doesn't lie on the line. Again, 0, 0, or the origin is the easiest one to pick. So I'm going to go ahead and put that in and see what that tells me about shading. If I have 0 plus 0 is less than 2, if I simplify that, 0 is less than 2, which I know is a true statement. So there's where 0, 0 is. So everything on this side should be solutions to the equation. So you can see there that that's the side of the line that we want to shade. All right, I want you to go ahead and stop the video here at this point, and I want you to try C and D on your own, and when you turn that back on, the video back on, I will graph those for you, and so you can check your work, and then you are ready to do your homework. All right, part C, I'll go ahead and explain here. Again, this is a horizontal line through y equals -1, and because it is greater than, I will draw a dashed line there. And again, it's everything greater than -1, so my test point there is 0, 0. So 0 is greater than -1, that is a true statement. So I'm going to shade everything on the side of the line where 0, 0 is, so I will be shading on that part of the line. Okay. And if I do something similar here for part D, again, think about graphing the related equation with the equal sign in there. So if I put 0 in for x, -4 is your y value. If you put 0 in for y, again, you get -4 for your y value. So these are your two ordered pairs. I'm going to use a solid line here because it is less than or equal to. So there is the boundary line. My test point is 0, 0. So I'm going to plug that into my equation. So I have 0 plus 0 is less than or equal to -4, or 0 is less than or equal to -4, which is false. Okay, that's false. So because 0, 0 gave me a false response, I am going to, false statement, I'm going to shade on the opposite side of the line from 0, 0, indicating that all the points on the other side of the line are solutions to the equation. Okay. Again, go ahead and try your homework on this, and we will continue in this section on Monday, and I'll answer any questions that you have on Monday.